Welcome to Environmental Sustainability. Today we're going to talk about pollution and sustainability as we move towards the future. So what exactly is pollution? What are pollutants? So pollution is a substance in the environment that, because of its composition or quantity, prevents functioning of natural processes. And it typically, when we talk about pollution, we're going to talk about anything that produces undesirable environmental and health effects. So we see that the big one that people tend to talk about are the ones that are going to cause health effects because we're concerned about our health. We want to live long. We want to have happy lives where we feel good. And that is where you're going to hear a lot about pollution and how it is affecting us and why we want to not only decrease the amount of pollution because of the environment, but also because of our health. So a pollutant is any material that causes pollution, usually byproducts of some desirable action, so something that we want to get done, but there's going to be some kind of byproduct to it, usually when we talk about agriculture. So, we want to farm, we want to have crops and food, but then there's going to be pollutants along with that, as well as we're going to want comfortable homes. We'll talk about that in a moment. And we want to be able to use transportation and everything that goes along with that. An example is mercury from mining, cholera in unsafe water, and then light and noise pollution as well. Pollutants, almost anything can be a pollutant. Too much of anything is a bad thing, like they say. So if something results in undesirable changes, then it is considered a pollutant. Undesirable changes can be aesthetics, meaning, litter, it looks ugly, we don't like the way that it looks, we don't want it drifting around. On ecosystems, negative effects or undesirable changes on ecosystems, meaning fish or forests will die off. And then on human health, obviously, water contamination with waste is an excellent example. So the effects can be direct, such as poison. Okay, poison in our water is going to be a direct one, or indirect, a chemical destroying the ozone layer that maybe we don't see it, but ultimately it is having a negative effect on that ozone layer, which is then going to have a negative effect on us. They can range from local, contamination of a well, contamination to one water source, or to global, such as ozone-depleting chemicals. Pollutants in the environment. So pollutants come from its central activities, growing food and crops, making sure that our homes are comfortable, whether they're warm, whether they are cool in the summertime, energy consumption, transportation, as well as industry. Increased population and consumption have made the problems more pressing in recent years. So as much as it has always been bad, and as much as we saw that we had detrimental effects on the environment starting way back when the Industrial Revolution started, we really see that it is becoming an increasing and exponentially worse problem because our population is growing exponentially and our consumption along with that is increasing as well. We like the lives that we lead, and we are continuing to consume, and as there's more of us and more of us are each starting to consume more and more and more, and we're living these lavish lifestyles, we see that is becoming a bigger and bigger issue as the years go on. Many products are non-biodegradable, so that is an even bigger issue. If something is biodegradable, yeah, we don't want to constantly be using it and to add it to landfills, but if it is non-biodegradable, then that's an even bigger issue because they do not break down, so they are constantly accumulating. This just shows you different categories of pollution. Obviously, the different pollution that we talk about. We talk about water and land pollution a lot, and you hear about air pollution. And the big thing with air pollution is that we see that there's particulates, there's acid-forming compounds that are going to cause that acid rain, and then you have smog, and also CFCs. So we've done away with CFCs, and that's what really depleted our ozone layer. And I always give this as an example for something positive when we talk about environmental science and is it really sustainable into the future. We see that CFCs are no longer used. They were the biggest component to the depletion of the ozone layer. And what they started using was HCFCs, and HCFCs depleted the ozone even less. And now what we're actually using are HFCs. And HFCs have no negative effect on the ozone layer. So previously we used CFCs for aerosols in our sprays. We used CFCs in refrigerants. Freon was a CFC. So we needed these to keep our homes cool, keep our food cool in our refrigerators, and we needed them in our aerosols. But we were able to switch. Innovations were able to move us forward so that we could move away from CFCs and now switch to the HFCs. You still hear people calling the substance Freon. Freon isn't used anymore. People still call it Freon. Oh, you need your Freon refilled in your car, but really we're using an alternative, which is an HFC version of Freon. And then when we talk about water and land pollution, you have solid waste, you have toxic chemicals, pesticides, nuclear waste, which we've talked about previously, nutrient oversupply, where we talked about fertilizers and how we're constantly adding to it and we're creating that shift and decreasing that balance. Air pollution, the atmosphere contains many gases, so it's not just oxygen, not pure oxygen. Air does consist of nitrogen gas, oxygen gas, water vapor, argon, as well as carbon dioxide. There's 40 trace gases as well. Most of it is made up of these, but then there are 40 other ones as well. And then there's also aerosols, which typically when we talk about aerosols, they are a bad thing, but they could be something that is not completely negative. You have microscopic liquid or solid particles, dust, pollen, sea salts, etc. from land and water. They do make up our air. Pollen, not necessarily a bad thing, but it is an aerosol. If we talk about CFCs, that is a negative aerosol or a bad aerosol. The Industrial Revolution greatly changed the mixtures of atmospheric gases and particles. So previously to the Industrial Revolution, we saw this balance in the way that things should be, and now we are putting too much carbon dioxide into the atmosphere, and our plants and photosynthesis are not able to remove it fast enough and make that oxygen, and we're throwing everything off kilter. So air pollutants are any substances in the atmosphere that have harmful effects. So when we talk about pollutants, we're talking about anything that's going to have a harmful effect. 3 factors determine the level of air pollution. You have the amount of pollutants entering the air, the amount of space into which the pollution is added, as well as the mechanisms that remove pollutants from the air. The troposphere is the layer atmosphere. It's that lower atmosphere. It's the site and source of weather, water vapor, and clouds. And pollutants are usually removed within hours or days. They don't stay in that troposphere. Pollutants in the stratosphere, above that troposphere, resist cleansing. So that's where we see an issue, because they are going to stay there and they are going to eat away at that ozone layer. So ozone-depleting chemicals, chlorine, bromine, they're going to deplete the ozone primarily in the stratosphere. In the troposphere, temperatures decrease with height. In the stratosphere, we see that the temperatures increase with height, and this is just a nice diagram to show you how the temperature changes as we move up away from the Earth. Processes that produce air pollution: incomplete combustion of organic compounds, fossil fuels is a big one, as well as paper, food, plastic. The products create problems before being removed. Evaporation of volatile substances, wind-blown dust and other particles. There are 2 different types of pollutants that we talk about: primary and secondary pollutants. Primary pollutants, they're going to be direct products of combustion, evaporation, particulates, VOCs, carbon monoxide, nitrous oxide gases, sulfide oxides, sulfur oxides, lead, air toxins. These are all going to be primary pollutants. Secondary pollutants are formed by the primary pollutants, such as ozone, peroxyacetyl nitrates, sulfuric acids, nitric acids. These are all secondary pollutants. And this just gives you a nice diagram of the difference between our primary pollutants and our secondary pollutants. So U.S. emissions of 5 primary air pollutants. You see fuel combustion refers to fuels burned for electric power generation, like we talked about. We need, in order to make electric power, we are going to burn fuel, as well as for space heating. So both of those are going to make up the fuel combustion component right here. So if you look at this diagram, we see that carbon monoxide, all right, a lot of it is coming from highway vehicles, all right, transportation. Okay. Down here, if you look at the VOCs, once again, transportation along with industrial processes, these are going to be major components. Nitric oxides, transportation. Okay, so you see this reoccurring theme where transportation is having a detrimental effect on our environment. If you ever go out to LA, they have smog issues because there's not a lot of mass transit. You see that a lot of people own cars, 1, 2, 3 cars, and they're constantly on freeways. And this transportation, everyone taking their own car and not carpooling, is adding to this vicious cycle. The greenhouse effect: without an atmosphere and its gases to trap the heat, Earth would be very cold. So we do want greenhouse gases in order to keep our Earth at a reasonable temperature so that we can survive in it. But molecules in the atmosphere trap the energy. The energy bounces between the atmosphere and the surface of the land and water. And we see that the greenhouse effect, where we're trapping this heat, it's caused by the energy warming the Earth's surface and lower atmosphere. So it's a good thing to a certain extent, but if we push that effect further and further and further, everything's going to heat up, and we see that it throws our ecosystems off balance, and it's going to decrease biodiversity. Forcing factors, this is a term that we use. The warmth of the atmosphere depends on internal factors and external factors. Internal factors include oceans, gases in the atmosphere, snow cover, sea ice. External factors are going to be solar radiation, Earth's rotation, slow changes in the Earth's orbit, all right, stuff that's going on in outer space. Radiative forcing is the influence any factor has on the energy balance of the atmosphere, system, ocean system, land system. All right, the effect of a positive forcing factor causes more warming. A negative forcing factor is going to cause cooling. So what we have too much of are these positive forcing factors. Some factors include water vapor. CO2 is a major one for us. Like I've said, other gases, these are all greenhouse gases which are going to increase our temperature. Light energy in the atmosphere is converted to heat energy at Earth's surface. The infrared heat energy radiates back to space, so that's not something that's influencing our temperature. In the troposphere, greenhouse gases absorb some of the infrared radiation, re-radiating it back towards the surface. You have nitrous gas, nitrogen gas, oxygen gas. They do not do this, so they are not considered greenhouse gases. Greenhouse gases are a blanket, insulating the Earth and delaying the loss of infrared energy or heat back to space. Without it, Earth would be negative 19 degrees Celsius. Okay, freezing is 0, so it would be below 0 instead of 14 degrees Celsius above freezing. And life, as we know it, would be impossible. Our global climate depends on Earth's greenhouse gases. Changing concentration is going to change our climate. Changing climate is going to affect the living organisms on our Earth. So the rise in carbon dioxide levels, this is the biggest thing that we talk about in this course. Carbon dioxide levels, the fact that they're constantly rising is a major issue. So we're constantly burning these fossil fuels, which is going to increase CO2 levels. About 1 kilogram of fossil fuel burn produces 3.7 kilograms of CO2. 10 billion tons or gigatons of fossil fuel carbon is released each year, a 2.5% increase, and it's only going to go up if we don't change things. Half of the carbon dioxide comes from industrialized nations, 5% comes from cement production, but it is put in with fossil fuel emissions. So when we discuss fossil fuel emissions, this 5% is clumped in with that. CO2 accounts for 20% of greenhouse warming. All right, that is an alarming number. Just CO2 alone is responsible for 20%. Climate change skeptics, they're always saying that global warming isn't real, climate change isn't real. Okay, they say that the CO2 comes from natural sources. They say that the Earth is constantly warming and cooling, which is true. We've had ice ages, we have had periods of extreme heat, but the rate that we're seeing is unprecedented. It's not like it's ever been before throughout history. So this is just not true. It does not come from natural sources. Studies show that the release of carbon has tripled over the past 50 years. That does not happen in history. We see that the Earth changes temperatures through millions and millions of years, and we see that the shifts take a very long time. For something to happen 50 years in the big scope of things, it's like a millisecond in the history of the world. So it is an alarming rate, the fact that our carbon has tripled over the past 50 years. This shows you how we were gradually increasing, and then once we got to the Industrial Revolution, okay, and we moved forward, we started to see this exponential growth, and now we see that it is actually getting worse and worse. So we need to figure out a way to make this more sustainable, to get our numbers down, to make sure that we're not continuing this exponential growth. The effects of climate change: higher temperatures, rising seas, heat waves, droughts, intense storms, season shifts, melting ice. These are all happening now. They're only going to get worse, and we don't want this to happen because Earth will ultimately become uninhabitable. Rising fossil fuel use will increase greenhouse gases. At the rate that we're going, it's estimated that emissions will rise 35% by 2030 and 100% by 2050, which might seem like a long way away, but it's really not. It's going to creep up quick. Modeling global climate, they actually use these supercomputers, and they have these algorithms that create and model atmospheric, land, and ocean processes, and they can map out the potential impacts of rising greenhouse gases, and the outlook is not good. So water pollution, talked about air pollution, now we talk about water pollution. There's two types that we talk about here, two sources, point source pollution and non-point source pollution. So you have point source pollution is easy to identify and regulate, easy to monitor, factories, sewage systems, power plants, mines. And then you have the non-point source pollutions, which are poorly defined and scattered agricultural runoff. We're not sure how much comes from which source. Stormwater runoff, we're not sure where this pollution exactly came from, or who's the perp for this. And then atmospheric deposition. Strategies to control water pollution: reduce or remove the source, which is not always easy to do. Best for non-point sources. And then treat water before release is best for point source pollution. This gives you an idea of point source pollution, where we are directly dumping things into the water. But then you have non-point sources, where from the city, from the suburban areas, we're going to have pollution make its way to the watershed. There's different types of pollution in wastewater. You have debris and grit, which are larger. Rags, plastic, sand, gravel, they're flushed down toilets or in storm drains. Then you have particulate organic matter, fecal matter, food waste, toilet paper that settle out in still water. You have colloidal and dissolved organic matter. They're fine particles of organic material such as bacteria, urine, soaps, and detergents. And then you have dissolved inorganic material. When we talk that these are the things like fertilizer, nitrogen, phosphorus, and other nutrients from waste and detergents. All pesticides, heavy metals, and toxic compounds are also part of the pollution in wastewater. Solid waste, where you have landfills and you have combustions. Municipal solid waste, or MSW, total of all materials, trash, refuse, and garbage thrown away. From homes and small businesses, it is collected by local governments. It is not hazardous or non-hazardous industrial waste. In 1960, the United States produced 2.7 pounds per person per day of MSW, but by 2012, we see that per person made 4.4 pounds per day of MSW. It's enough garbage to fill 95,000 garbage trucks per day. So areas may not pay attention to what is thrown away despite restrictions. hazardous materials, paint, motor oil, etc., are discarded in the trash. So this is where people might be educated and they might know, but it might be something where they're too lazy or they don't really care. So it's important to further educate the public about these hazardous wastes, but you're still going to have issues with this because of the way that people are. Different municipal waste, you see that paper is a major part of MSW, food waste also. These two together, okay, they make up over 40%. Okay, in some estimates, it could be up to 40% of our MSW is just from paper, paperboard, and food waste. Modern disposables, much of the increased waste in the United States is from disposable products, single-use paper cups and plates. Instead of being recycled, discarded, cardboard produces greenhouse gases when decaying, which is going to further cause more issues with global warming and climate change. Plastics are cheap and easy to make, but do not decay easily and may release toxic gases eventually. So non-biodegradable, they're going to sit in landfills, they're going to continue to accumulate. The amount of components of waste and its fate vary greatly from country to country. So we see that some countries are very good at disposing of their waste and other countries do a terrible job. Wealthy nations produce 100 times more trash per person than poor countries. So we are a wealthy nation. We are constantly consuming and we are constantly throwing things out. Think about whenever something breaks, do you go to get it fixed? Well, sometimes it's cheaper to just buy a new one, and that's what we do. We throw out the old one, buy a new one. The old one ends up in a landfill. So in a poorer country, it might be very expensive to get a new one, and it is a better idea to fix something. So they're going to fix it, and they're going to continue to use it, and that stuff doesn't end up in a landfill somewhere. You have trash escapes, which is hard to combat. If not disposed of properly, trash can cause severe environmental trouble. It reaches beaches or ocean water. Even remote ocean patches contain trash. You have garbage patches or gyres. So these garbage gyres, currents that move floating plastic in the oceans, you have these huge garbage gyres that accumulate in the ocean. We see off the coast of California in the Pacific Ocean, they have these garbage patches that are miles and miles and miles long, that because of the way the water currents are, they just get all pushed together and they just are growing. The Pacific Ocean's garbage gyres, plastic weighs 6 times as much as the plankton in the area, which is very concerning. So plastic in the ocean is very dangerous. Here, this just shows you some of the giant gyres. Of course, there's plastic everywhere in the ocean, but we have these gyres or these patches in certain areas because of the way that the water currents are. So plastic in the ocean, like I said, it's very dangerous. It can leach or absorb chemicals, DDT, PCBs. Floating plastic entangles animals. You have discarded, abandoned, lost fishing gear make up about 10% of marine debris, and this lost fishing gear ends up trapping organisms and what's called ghost fishing. 70% of endangered North Atlantic right whales have been entangled. So you see that it's not just little fish are getting caught here and there, it's that all sorts of organisms are getting caught, and it is ultimately killing these organisms because they're not able to continue to search for food. They're trapped. We're not collecting them and eating them, so it's not helping us, it's not helping them, and it's decreasing biodiversity. Very small pieces of plastic are mistaken for food and kill animals that eat it. It also ends up on our dinner plate ultimately. So these are called microplastics, and microplastics are very small pieces of plastic that they're non-biodegradable, they're not going to decompose, and ultimately they're going to, a fish might think that it's a piece of food, it's going to eat it, it's going to end up in its tissue, and then we can actually end up eating it when a fisherman catches that fish and puts it on our dinner plate. Also, we see that a lot of organisms get caught in the nets, get caught in different things. Many people have seen on Facebook or online where sea turtles have like a spoon stuck in its mouth or in its nose, or they see that certain things like this where maybe this otter got this trapped around, it couldn't really get it off when it was younger, and now as it's growing, it's getting tighter and tighter and tighter, and it's not able to get it off. So these things are killing animals all around the world. Toxicology and chemical hazards. Industrialization and technology use chemicals, no matter how you want to think of it. Cleaners, pesticides, fuels, medicines, paints. All right, all of these things are chemicals. They may be good for us, they might be helping us, but somewhere along the way, it is going to have a negative effect on the environment. Exposure is through ingestion, breathing, the skin, direct use, or by accident. So toxicity is a condition of being harmful, deadly, or poisonous. Depends on exposure and dose. Okay, so something might be toxic. We don't really worry about it because we're not constantly getting tested for it, but we are getting exposed to it. The amount absorbed by a sensitive organ is going to be different depending on what exactly that chemical is. Toxicology, it studies the impacts of toxic substances on human health, the presence of a substance versus health problems. So the ones that don't cause major health problems, we don't really thoroughly study them, and the ones that have major health problems, we're constantly talking about and we're constantly researching. But it doesn't mean that the ones that we're not researching aren't important or having negative effects on us as well. Chemical hazards are everywhere. Different people have different thresholds of toxicity. Children and embryos are most sensitive. So that's where we really worry about. We don't want children to be exposed to them, and we don't want embryos to, or we don't want women to miscarry because of this toxicity. Substances can be dangerous to fetuses, young children, or reproductive age adults. They can cause birth defects or miscarriages. We have these three different terms that we typically use. You have mutagens, substances that cause mutations. Okay, a mutation is going to be a change in the DNA. The change in the DNA can have a negative effect. They can actually cause cancer. You have teratogens, which are going to be substances that disrupt development. And then you have carcinogens, which are substances that cause cancer. Heavy metals such as lead and mercury are very toxic. That's why we see lead is not used as much as it once was. Lead used to be in paint. It used to be used in building materials, and now we see that we're moving away from that because of its toxicity. Mercury as well. Biological hazards. Humans have always battled bacteria and viruses. The Black Plague and typhus killed millions and millions. Vaccinations were developed in the 19th century. Bacteriologists discovered most bacterial diseases back then. And now we see that vaccines have really taken us a long way to make sure that our population doesn't greatly decrease the way every time something comes around the way that it did when the Black Plague was around. But now we're moving to a place where people are actually not using vaccines. They've worked so well that people don't realize what it's like if you don't take them. And now people are anti-vaxxers. And by not using vaccines, we're seeing that now something like measles in the recent news, measles is spreading now because people are not getting the measles vaccine because they think they don't need it. And now anyone that can't get the vaccine, like someone that has a weakened immune system or someone that's very old, they're not going to be able to get that vaccine because they might not be strong enough to fight off that dead or weakened version of the virus or the bacteria that actually is a vaccine. And then it's not really fair to them because they would love to get the vaccine, but they can't get it. And now this person that can get the vaccine is not getting it and is causing the spread of these diseases. The 20th century brought virology, antibiotics, immunizations. All of these things increased our population, increased our lifespan, and ultimately led to global eradication of things like smallpox and a victory over polio, which was a major problem. But diseases are still responsible for 20% of deaths. We still have diseases like respiratory infections, tuberculosis, HIV and AIDS, diarrheal diseases from Salmonella and E. coli, as well as malaria. So environmental sustainability. So as we wrap up this course, it's important to understand that after everything we've discussed, okay, where can we go moving forward? What are our roadblocks? So environmentalists are constantly working towards a sustainable future. Our constant consumption and modern lifestyle are not conducive to sustainability. We need to decrease our consumption and we need to really change our lifestyle. So progress will take a joint effort between economics and politics and the consumers. So politicians need to work towards subsidizing sustainable efforts. We need to give money to the efforts that are going to help to move us towards a more sustainable future. Big business needs to create innovations that are going to give consumers options that are affordable. So right now we might have options, but if they're not affordable, people are not going to switch them. And then us as consumers, we also need to choose products and services that support sustainability. Many people don't think that we really have a choice or we really have an impact, but we do. Okay, if we start choosing products that are more sustainably created and are biodegradable, then the service industry, the big business, will be forced to shift to what the consumer wants, and we ultimately will have a great impact on moving towards the future. So apart from picking better products, we also have to live more modestly, and we need to recycle more. Some things that we run into, it's all great if we all had all the money in the world and we can just pick the more sustainable option, but most sustainable cities are in wealthy countries. All right, making other cities to be sustainable cities is going to require planning and investment. Sustainability is hard in slum areas. We have to provide jobs in order to be sustainable. That involves collecting trash, building sewers, composting, growing food. Push people to do things that are more sustainable by paying them. Giving representation to the poor and the powerless so that they can fight the good fight. And then we also need community organizations to deal with basic issues and educating the public. When a city's slums become more livable, the entire city benefits. So keep these things in mind as you move forward, as you talk to other people and have discussions with people. Why aren't we there yet? Why haven't we made the changes? Why isn't it as easy as just completely switching?